So this is a very famous problem, again interview based problem. So let's say you have been given an array of size n. Okay, now the question is you have to find all the distinct triplets having sum equals to 0. So you have to find all the distinct triplets that are having sum equal to 0. Okay, as simple as that. I mean, there is an array, and if let's say there is an element x here, y here and z here, such that x plus y plus z is equal to 0, then this is one of your solutions. So you have to print x comma y comma z in one line. Now let's say in another line there is x dash and then y dash and z dash. So let's say these elements are also there, such that x dash plus y dash plus z dash is equal to 0. Then you have to print that also. Similarly, you have to print out all the triplets. Okay, but there is an important thing written over here. I want distinct triplets only. Okay, so here let me tell you the meaning of distinct triplet. So first let me ask you, I mean that should be a question from your side. Okay, what do you understand from this distinct triplet? From this word distinct, do you understand distinct in terms of index? Do you understand this thing? Yeah, you should understand like that, because the interviewer needs to tell you that, and if you have a doubt you need to ask it. Others, are you clear or not? I mean, this is concerning if you're not clear. So if let's say there is a 2 over here, and then there is a -1, and then there is a -1, will this and this be a part of your solution or not? Yes or no? Yes, it will be. But let's say there is another 2, there is another 2 like this. Will this and this be a part of your solution, be another part of your solution? Can I say these two are to be treated as distinct solutions if the indices are to be considered differently? Can I say it? Yes, I can obviously say that, right? Why I can say that? Because the index of this 2, the index of this 2 corresponds to this, and this 2 corresponds to this. Okay, that is the reason this is being treated differently from this. But the question here wants to talk, it wants to talk in terms of value. It wants to talk in terms of value. So it says that, hey, I am not going to, consider this and again this, because, so I'll tell you what is the meaning of distinct triplet. Distinct triplet means that let's say you have ABC and then you have PQR. Okay, then this must not be a permutation of this, right? And this must not be alike this. That is the meaning of distinct permutation. I repeat, that is the meaning of distinct triplet. This must not be a permutation of this, and this must not be alike this. Okay, that is the meaning of distinct triplets. So if you have considered 2 minus 1 minus 1, then you should once again not consider 2 minus 1 minus 1. Okay, because this is extremely alike this. Okay, this is totally alike this. Similarly, considering something like -1 -1 2 was also foolish, because this is again a permutation of this. Cool. So let us take an example. So let's say my array contains -1 0 1 2 -1 and 4. So can you guys tell me the solution set for this? So I can have this -1, I can have this 0, and then I can have this 1. Okay, tell me one thing. After you have got this -1, this 0 and this 1, would you want to have another triplet where you have this -1 and then this 0 and this 1? Would you want this to come after this? Would you want it? Yes, no, quick. You would not want. You would not want. Why? Because distinction has to be maintained in terms of values. Yeah, and what is the another one? Another one is if I take -1 and then 2. So this -1 and this 2. And of course you should not consider permutation of this or permutation of this. So here there are overall 2 triplets. So the question wants you to print those triplets out. Okay, you should be able to print out those triplets to me. That is the requirement over here. So tell me, what is the approach for this? Brute force approach. How many of you are up with brute force approach? N cubes using 3 loop. Okay, n cube using 3 loops. That makes total sense. So you can simply use 3 loops and then you can solve the problem. But while using 3 loops, how would you ensure that the solution set is not being duplicated? Yeah, that is exactly what my question is. How would you ensure that the solution set is not being considered over and over again? So one of you said that one way to do that is to store these solutions in a set. Okay, so if you store them in a set, that way you can avoid that. But I don't want you to use set data structure because set has its own complexity of insertion. So Divya says that sort and store each solution set into, again, if you are storing them in a set, I'm not so happy with that. I do not want you to use set. So any other idea? Create a separate array and put one for used element. Okay, create a separate array and put one for used elements. So yeah, that way what Ashish is trying to say is he'll have a visited array kind of thing where everything will initially be 0, 0, 0 and 0, 0, 0. And let's say he has considered -1, 0 and 1 to be one triplet, then he'll convert this to 1, 1 and 1 to denote that hey, these three have been taken. But my question is that later on in your for loop that you have, so there is a for loop where your I goes from 0 to n-1, and then again there is a for loop where j goes from I plus 1 to n-1, and then there is a k that goes from j plus 1 to n-1. Are these the kinds of loops that you will write? Yes, no, right? These are the kinds of loops that you will write. Okay, now my question is that after considering -1, 0, 1, this loop will make you consider 0, 1 and -1. How will you ensure that this is something which is same as this? How will you ensure it? Because corresponding to these you will see 1, 1 over here, but corresponding to this you will see 0 over here. So can you tell me how would you exactly want to ensure it? Right, so that way you will not be able to maintain it, but there are very easy ways to maintain it. I would say very easy ways to maintain it. I would say something like this. Okay, how many of you are thinking about sorting it? Yeah, sort the original array and then cool, that makes sense. So even in this approach, if I just perform sorting, then I'll be able to get rid of duplicates. Okay, so how is sorting going to be helpful? Will somebody answer me? Why do you want to sort it? So guys, think of it in this way. If I sort an array, after sorting an array, what happens? That similar elements are clustered together. Yes or no? Yeah, similar elements are clustered together. They are, right? So if you sort an array, so let's say this had one more 0 in it, just for convenience. So after sorting it, you would have got -1, -1, 0, 0, 1, 2 and 4. Okay, so these -1s are together, these zeros are together. Okay, now the thing is that if let's say you consider this thing as your first element, okay, so is it right that this is like your first element of the triplet, which is this is like your second element of the triplet, which is this, and this is like your third element of the triplet, which is this, correct? So let's say this is your first element, okay, then you would have got some second and third element from this area, Now my question is, in the outer for loop, when your I moves from 0 to 1, okay, would you again want to consider this -1 as your first element? You should not want to do that, and there is a common sense behind that. Guys, others think. I want everyone to think. Would you want to consider this -1 again as your first element? Because tell me, when you have considered this -1 as your first element, and for I equals to 0, when these two loops have run, you would have captured this 0 with this 1, right? And you would also have captured this 0 with this 1, but let's say there is an intelligence over here. Let's assume it. There is an intelligence over here to not consider this 0 this one, after this 0 this one. Okay, so now my question is, when this loop runs again, would you want to consider this -1 again? No, because if you consider it again, then from this much of area you might once again get 0 and 1, which will be totally same as this. So what should be the logic that should be considered? The logic should be like this, that I'm going to write these 3 loops again. So if let's say my outermost for loop is something like this, I varying from 0 to n minus 1, right? Now here if you see that a of I is equals to a of I minus 1. If a of I is equals to a of I minus 1, which was the case over here, would you want to consider this element as first and continue with your iteration? Would you want to do it? Yes, no? You would not want to do it. You would want to skip this step. And how do you skip a step? How do you skip a loop? Can somebody tell me what is the keyword to skip a loop and move on? Continue. You'd want to continue. You'd want to continue to the next iteration, where the value of I instead of 1 now move to 2. Now an important thing to understand over here is that can there be an edge case over here, because a of 0 can get compared to a of 0 minus 1. Okay, so there should be one AND condition over here, that I positive. If I is positive and this is the case, then only I'll continue, because if I is 0, that means this is the first element and this is being seen for the first time. So I must consider this as the first element of whatsoever triplet I am trying to generate. Now, so this step will ensure that out of all the triplets that I have got, their first elements are never equal. So this will just guarantee that the first element of all my triplets are never equal, correct? Have I taken care of my second and third elements? But can you take care of them? Can you use some brain and take care of them? Something similar like this. Yes, you can have same kind of condition coming up. Just think of it in this way, that when this is not the case, then only you will enter and perform these 2 for loops, right? So let's say you enter, okay? Now you enter and your j varies from I plus 1 to n minus 1. Now tell me one thing. If let's say there was an array where there was a -1 over here, and then there was a 1 over here, and then there were many other things. So you considered this -1 and sorry, this was not 1, let's say this was 0 and this 0. You considered this -1 and this 0, and then from here you found out a 1. Okay, now let me ask you something. If let's say this is your I and this is your j, and let's say at j plus 1 index also there is a 0. At j plus 1 index also there is a 0. For this I, if you have considered this j, would you want to consider this j plus 1 also for this I? No, you would not want to consider it, right? So as simple as that. So the same condition should come over here as well, that if I ever happen to see that my a of j is same as a of j minus 1, then what will you do? What will you do? You will simply skip this iteration of j, right? And you will move on to the next value of j. Very good. So you would simply want to continue. But again, there should there be a condition over here? Should there be a condition over here? Yes. It should be there, right? Why should it not be there? Because if let's say you have a -1 over here, which is your I, and let's say this is your area, and let's say there is a -1 over here. Let's say there is a -1 over here and there was a 2 over here. Would you want to consider this or not? Would you want to consider this as second element of your triplet or not, where the first element is this? You would want to consider it, right? But would you want to consider this after you have considered j as this? Would you then want to consider j as this? No. So the first thing which is there will always be considered, but second thing, third thing, fourth thing, if they are a copy of their previous thing, then they will not be considered. So what you can do is that if you see that j is greater than I plus 1 and then this is the case, then you would want to continue. Okay. Similarly, can you do it for k also? Your k will go all the way from j plus 1 to n minus 1. Now again, similar conditions. Let's say you had -1 and then -1 and you saw 2. Okay, now after considering k over here, you would not want to consider k over here again. Okay, you would not want to do that. So you will write that if k is greater than what? K should be greater than what for that check to kick in? Yeah, k should be greater than j plus 1, because the first thing will always be considered. If k is greater than j plus 1 and a of k equals to a of k minus 1, then you would want to continue. Only if all these three checks pass, then only you will consider ai, aj, ak their sum, and if their sum is 0, then you would want to print it out. So this way, without using any map or set, I have got my job done. And this is a very, very important approach where you can reduce the amount of extra space just by sorting, because sorting is going to take you n log n time. The core logic is n cube, right? So still you are able to say that, hey, I have solved this problem in n cube, but I haven't used any extra space for that. I have just sorted it. Okay, and this is let me tell you, this is easy, this is cheap, and this is asked in interviews a lot. Okay, so remember it throughout. Cool. So everyone knows n cube approach. Now the question is, can I optimize it? So let's say you have ai plus aj plus ak equals to 0. I'm asking this question from everyone, guys. I'm asking this question from everyone. In your outermost for loop, you fix this thing, right? You fix this thing. So once you have fixed this thing, can you tell me what should be the other two pairs? Sorry, what should be the other two elements that you should look out for? Can I say that they should be such that their sum should be the negation of this thing? Can I say it? Yes, no? Right? I can say it. So technically what I'm trying to say is, let's say let's say you happen to sort the array, okay? And let's say you got a -5 over here. So, and this was your index 0. So let's say if this was your -5, then in the portion from here to here, you are interested to know that how many such pairs are there such that their sum is equal to 5. And can you get this thing done? Right? Cool. And how can we get this thing done? Can I use 2 pointers for this? The answer is yes. I can very well use 2 pointers for this. Right? But using 2 pointers, I can very easily calculate that how many pairs are there. Correct? I can very easily calculate that how many pairs are there. So let's say there was a 1 over here, and then there was a 4 over here, and then there was another 1 over here, and then there were 2, 2, and then there were 3, 3. Okay, so ideally what all are the things that you would want to print? You would want to print -5, 1 and 4. Would you want to print -5, this 1 and this 4? Would you want to print them? Yes, no? You would not want to print them. Next, what would you want to print them? For this -5 as your first element, can you see any other distinct triplet apart from -5, 1 and 4? Yes, that is -5, 2 and 3. Now if indices were to be supposed differently, then 2 into 2, 4 such pairs would have come. 2 into 1, 2 such pairs would have come. But elements are to be thought of differently. So can I generate these pairs in order n square time just by using 2 pointers approach? Is it possible? Remember the question where we were finding count of pairs? Yes, we can do that. Very good. So what I can do, let's take one more element. There was a 0 over here. So this is a sorted space. So you can start from here and here. Now if you see that the sum of this is smaller than the required sum. If it is smaller than the required sum, which pointer will you change? Let's call them j and k. Which pointer will you change, j or k? If it is smaller, you will change your j. J will be plus plus. And if it was greater, then you would have done k minus minus. So now you come over here. So you know what to do if let's say you got a sum which is greater than 5. Had it been greater than 5, then which pointer you would have changed, j or k? In that case you would have changed k. But if the sum is equal, what would you want to do? So first you would want to store this as one of your answer, And then what would you want to do? Would you want to keep updating this j as long as you do not get a new element? Yes, no? Yeah. And you would want to keep on changing this k as long as you do not get a new element. Right? Cool. Now again, at this point of time, what would you want to do? Again, you are at 2 and 3, which are your new elements. So you print them out, and again you keep on changing them as long as you do not get a new element, and you keep on changing them as long as you do not get a new element. At this point of time, this loop is going to break, right? So this way, what I am going to do is, for this particular element, which is A0, for A0 as my first element, I am able to generate all the possibilities for my second and third element in order of how much time? Order n time, because all I am doing is I'm running 2-pointer approach from here to here, and this length will be order of n, never greater than that. Correct? Cool. So this is the way, and my 2-pointer logic is written in a way which is ensuring that there are no duplicates. This 2-pointer logic is written in such a way. So what it will do, second and third pairs out of all my triplets will never be duplicates. They will never ever be duplicates. Actually, one more thing. Tell me one more thing. Let's say there was a -6 over here, and then let's say there was a 3 here, and then there was a 3 here. So at this point of time, when you see that this plus this is equal to negation of this, and both of them are equal also, would you want to break the loop here itself? Yeah, you would want to break. Correct? And I think this makes sense. Okay, how do you avoid the duplications of first element? Can I do it by using the approach that I just discussed for the order n cube solution? Yes, I can do that. Very good. So what I can do is, I will always consider my first element by using I. So I will vary from 0 to n minus 1. Now if I see that this I is positive and AI is equals to A of I minus 1, what would you want to do? You would simply want to continue. If this is the case, you would want to continue. Otherwise, what will you do? Otherwise, you will set a variable called as remaining sum. And what will be the value of remaining sum? For which 2-pointer approach runs? That will be nothing but minus of A of I. And now you will have a 2-pointer approach coming up over here, which will find out that from I plus 1 to n minus 1, from this zone to this zone, how many different pairs are there that are having sum equals to this much. Okay, and this is written in a way that this is not considering duplicates again and again. And why is that happening? That is only happening, see, I am able to write this code because I initially sorted my array. Yes or no? Right? Because I initially sorted my array. And I am able to write 2-pointer approach also because of the reason that I sorted my array. So can somebody tell me the overall time complexity of this approach? N square, right? Can we optimize by iterating I only for the negative value? Yes, I believe you can do that, because if you want to make a sum which is equal to 0, then one thing is quite obvious. And what is that thing? That thing is that one of the elements must be negative. You can do that. But sometimes the sum that can be expected from your side, this could be a non-zero sum also. It could be like 10, it could be k, and k can just be anything. By the way, did you realize one interesting thing over here? That although the question was for finding out triplets, listen very carefully, question was for finding out triplets. Okay, how many triplets can you have in an array of size n? Can you just tell me order of that? How many different triplets can you see? N cube, right? Still I am able to solve this question in order n square, wherein I am not just counting them, but I am considering them also. I am creating them and I am pushing them into a vector. So the number of triplets that I will get, the number of triplets, that will never be of the order of n cube. That will be of the order of n square. The point is that it would never ever happen that all the n cube triplets that you are having in your array, all of them are summing to 0. If the condition which is being enforced to you is the condition of distinction on the basis of values and not on the basis of indices. If it was on the basis of indices, then it would have taken you order n cube time. Don't you think so? Yes, no? Right? It would have taken you order n cube time, because there you should have considered this, and then again this, and then again this, right? So that is the reason you are able to solve this question in order n square time. Cool. That's it.